Hello and welcome, ladies and gentlemen. We are here in the Getting Started activity. This is Packet 5, Topic 2, Module 1. It's almost test time. So we'll just hop right into it. So it says, you've used circles to explore relationships involving triangles. Let's investigate what happens when you connect any 3 points on a circle to create different types of triangles. Number 1 says, construct a circle and label the center. Well, I didn't label it. This will be circle O. That's my center point. It says, then draw any 3 points on the circle. Draw chords, so draw any 3 points on A, B, C. Then draw any 3 points on the circle. Draw chords between the points to create a triangle. So you can see I've done that already, just to save a little bit of time before the video. So now we'll go, what is the relationship between the center of the circle and each vertex of the triangle? I'm going to adjust my iPad a little bit here. There we go. What is the relationship? Well, I know that from the center of the triangle, or excuse me, the center of the circle to each point on the triangle, there's a special name for this distance. It's called a radius. So all of them are radiuses, or radii. All distances are radii. So that's one thing that I know. But what do we know about the radius of one singular circle? All the radiuses, all the radii of one singular circle have a certain property about them that we know, and that's that they are all equal. They're all equal in length. Okay, so then equidistant, or equal in measure, I shouldn't say equidistant. So because they are all radii, they're all equal in measure. There you go. So compare your triangle to your classmates. What do you notice? We did this in class. We noticed a couple of things, different sizes, right, depending on how big your circle was. There are different types of triangles, right, because some of us maybe made something that looked like an equilateral triangle. Mine looks like kind of like an isosceles triangle. Maybe not exactly. This actually might be scalene, but it looks kind of isosceles, right? So all of our circles, or all of our triangles, excuse me, would be different types of triangles. So now number 4 says, draw 3 lines, each of which passes through the center of the circle and through the vertex of your triangle. So I didn't do this before the video, so I can do this really fast. Basically, these little dotted lines that I just created, now I'm going to make them solid. So I'm making lines that go from my vertexes, or my vertices, okay, through the center of my circle. There you go. Okay. So I have 3 lines, it looks like, and they all go through the center of my circle. So now that was number 4, so we can check that off. We did that. So now we have this little thing here. We're going to learn a new word. So the line segments you drew are concurrent lines. Concurrent lines, rays, and line segments are 3 or more lines, rays, or line segments intersecting at a single point. So you have 3 lines that intersect at a single point. So I just drew 3 lines, and they all go through the center of the circle. So this would be the point where they intersect at, and then my 3 lines would be 1, 2, and 3, right? So 3 lines that intersect at a single point. So that's what concurrent lines are. And then point of concurrency, so over here on the left side we have another new word. The point of concurrency is the point at which concurrent lines, rays, or line segments intersect. So what that means is, because the center of my circle is where all these lines intersect, this is also my point of concurrency. So these 3 lines are concurrent because they are 3 or more lines that intersect at one spot. And then the spot that they do intersect at is called the point of concurrency. So now number 5, are there other sets of 3 lines that pass through the center of the circle? Explain your reasoning. Well, okay, if I look at my circle, the way I like to think about this one, how many diameters could I draw? And I know that these are radiuses, but when I draw the other side of them, they will become diameters, right? So how many diameters could I draw on a circle? Well, you're probably saying a lot, right? Well, really, there's an infinite number of diameters that you could draw in this circle, and they all would intersect at the center point, right? They would all go through the center point, because that's the definition of a diameter. So are there other sets of 3 lines that pass through the center of the circle? Well, I know that there are an infinite number of diameters that I can draw that pass through the center. So infinity divided by 3, well, infinity is a number that is, it's not even a number, it's like a concept, right? It's so big that we can't really break it up. So dividing it by a finite number, so a number that's just like a number 3, infinity divided by 3 is still infinity. So there are an infinite number of sets of 3 lines that would pass through the center of the circle. And then the reasoning would look something like this. There's an infinite number of diameters you can draw, and we're looking for sets of 3. That's still an infinite number of sets of 3. So there you go. That was the getting started super short video. I hope you all have a wonderful evening. I will catch you in class. Have a good one. Adios.